Hi everyone, in today's video we will be talking about one of the trigonometric identities. Let's first of all meet with our identity, which is sine alpha plus beta. I think most of you have covered this trigonometric identity at school or university, but also in my opinion most of you don't know how to prove it. It's equal to sine alpha multiplied by cosine beta plus sine beta multiplied by cosine alpha. And in this video we will just try to prove this theorem. And we will use the geometrical proof of this theorem, and let's start by looking at the figure you see in the left hand side of the screen. And as you see, we have drawn one triangle here, which is right angle triangle, and then we divided one of its acute angles into two different angles, which are alpha and beta, and then draw the line here, and here we will draw another perpendicular line from A to point C, as you can see in the screen, and then we will draw from C to A another perpendicular line to AB, and also we can tell that AB and CD are parallel lines, and then we see that if the angle OBA is right angle, the ODC will be also the right angle. And let's try to prove our theorem, and also let's just find why this angle is equal to alpha. If here is alpha, which means that this angle is 90 minus alpha degree, because the total sum of angles of triangle is equal to 180, and if this is right angle and these two, the sum of these two angles should be equal to 90, and therefore 90 minus alpha degree. And also here, because of these are the same angles, we will write 90 minus alpha. Also this E, let's call this point O. EOC is 90 minus alpha, and as here is 90 degree, therefore we will get, because of the same reason we talked about in terms of this let's go OQB triangle, and here the ACK angle is equal to alpha again, and here is 90 degree, and this angle is 90 minus alpha, and again because of the same reason, total sum is equal to total sum of alphas. A triangle is equal to 1, 2, 3, because 3 angles is equal to 180 degree. Therefore, this angle will be alpha. And let's try to prove using the geometrical representation of our theorem, our compound angle formula. Sine alpha plus beta is equal to AB divided by OA. AB divided by OA. And let's divide AB into two parts, AE and EB. Let's write with the help of sum AE plus EB divided by OA is equal to, again let's just divide into two fractional element, AE divided by OA plus EB divided by OA. Here we should use the simple trick in order to get the final formula, the form of our formula, and let's start to write. we should find the line on the figure A, which will satisfy the case that AE divided by, for example, let's call it x multiplied by x divided by OA plus EB divided by y here multiplied by y divided by OA. As you see here, when we multiply these two fractional elements, we see that we will get the final form of AE divided by OA, and here we will get the second term EB divided by OA. But what should we add to the place of x and y? As you see from the formula, we see that sine alpha divided by cosine beta plus sine beta plus cosine alpha. You see that there are 4 individual terms in our formula, and here we see another 4 individual terms. In order to just make our formula and the ready formula similar, we should find the line here to get these angles, these terms, sine alpha, cosine beta, and etc. Let's start. AE, if we divide AE by AC, we can get the sine of 90 minus alpha, and which will but we should check the second part of this term. If we divide AC by OA, what we will get? This is hypotenuse of OAC triangle, and we will get the sine beta. And I think this is similar to the second term of our ready formula, and therefore we can write it. And let's change the color and write this term here. AE divided by AC multiplied by AC divided by OA, and this is equal to, again, AE divided by AC is, as you see, sine 90 minus alpha, sine 90 degree minus alpha, which is equal to cosine alpha, which is another identity. And here, in order to find the second term, we should think about it too. How can we derive the final formula? EB divided EB is also equal to, as you see from the parallelity of lines, this line is parallel to this one, this line is parallel to this one, therefore EB is equal to the CD. Therefore we can replace this term with CD divided by, again, let's write it y, let's keep it right, and OA. And if we divide CD by OC, we can get the sine alpha, because we have cosine alpha, and in the equation you see that we get the second term cosine alpha, and we need to get sine alpha here. Therefore we found out that the OC should be written to the places of y. Let's write CD divided by OC, and you can check it for the second part, multiplied by OC divided by OA. This is going to be equal to, what is CD divided by OC? CD divided by OC is sine alpha. Sine alpha multiplied by OC divided by OA. OC divided by OA is equal to, as you see, this is the hypotenuse of triangle OAC again, and when we divide, and here you see that CD divided by OC multiplied by OC divided by OA. CD divided by OC is sine alpha, and it should be multiplied by OC divided by OA. OC divided by OA, as you see here, is equal to cosine beta. And this is the second term of our final formula. And let's write the first term and second term, and sum them to find the final form of our equation. Sine alpha plus beta, which we were trying to prove, is equal to sine beta cosine alpha, the first term, plus sine alpha cosine beta. This is the end of our video. If you could learn something, please comment, like, and subscribe to my channel.